Everybody, this is a guided walkthrough for the Trickster challenge over at picoCTF.org. It's a medium level challenge in the web app hacking category from the picoCTF 2024 event. The description says, I found a web app that can help process images, PNG images only. Additional details will be available after launching your challenge instance. So it says here that the challenge is browser web shell solvable. That is technically true. It's technically true. We'll talk about a little bit about this in a second. But anyways, we're going to need access to our web shell to do this challenge. Let me go ahead and set up my web shell environment before we do this. The first thing we need to do to start the challenge is we need to click on the Launch Instance button over here. So the Launch Instance button is going to start up the web app, and the web app is going to be in a virtual machine. The way the picoCTF flags work for later years is that every user is going to have an individualized flag, which makes it harder for people to share flags. And that means that we're going to have to start up this virtual machine every time we do one of these challenges for these modern picoCTF challenges. Anyways, we can access the challenge after we start up the instance. We're going to see the timer over here, and we can go ahead and put the website in a new tab. So right click on the link, put it in a new tab, and then we can take a look at this page. So it says, welcome to my PNG processing app. That's interesting. So what the app here is supposed to teach us is it's supposed to teach us about insecure file upload. So one thing we're going to do to get ready to one thing we're going to do to take a look at what is in the app is to take a look and see if there's a robot.txt file. So robots.txt is a pretty common file that can be used to make sure that search engine robots only go to certain parts of the website. But one thing about the robots.txt file that is dangerous is that sometimes the robots.txt file can direct people to sensitive parts of the website, which is not what it was intended to do. But anyways, it says here to disallow these two endpoints over here. So the first endpoint is instructions.txt, and the second endpoint that we're not supposed to look at is called uploads. So this is a directory called uploads, and there's this text file called instructions.txt. So that makes us curious, of course. We're just going to go over to the instructions.txt endpoint. So in the instructions.txt endpoint, it gives us some very interesting information here. So the message goes, let's create a web app for PNG images processing. It needs to allow users to upload PNG images, look for the .png extension in the submitted files, and make sure the magic bytes match. It says, I'm not sure what this is exactly, but Wikipedia says that the first few bytes contain PNG in hexadecimal. That is the character, hexadecimal character 50, 4E, and 47. So after validation, store the uploaded files so the admin can retrieve them later and do the necessary processing. So we got a lot of information just by looking at these two endpoints. Let's talk a little bit about what's going on here and what we're going to be doing to complete the challenge. So we're talking about file upload attacks. File upload attacks are a type of web app hack where malicious files can be uploaded to a web server and then accessed on the web app, executing the code within the uploaded malicious files. So basically, we put some bad code in a file and then upload it and then access it, and then we execute the bad code. In order to perform a file upload attack, there are 3 conditions that must be met. Number 1, there must be a way to upload files to the web accessible location, to a web accessible location. This could be via web app or another service such as FTP or SMB. Second condition is the upload location must be known to us. So uploading a file isn't enough. We have to be able to locate the file as well, because if we can't upload the file, if we can't locate the file, then we can't access the file. And the third condition is the app must be able to execute code. For example, it has to be running something like PHP or ASP, one of these engines. So the first condition is the file upload condition. The app lets us upload files, and a lot of apps only let you upload files of a certain type. In this case, it must have the .png file extension, and it must include the magic bytes for PNG files. So we're talking about magic bytes. What magic bytes are is a file's magic bytes. These are the value of the first few bytes in the file, which identify what kind of file it is. So this is pretty common for all sorts of different files. The first few bytes in the file identify what kind of file it is, so that the proper program can be used to open it. So for example, here it's .png, and if we look inside of our Kali Links over here, we got the JPEG file here, right? What we can do is we can take a look at the contents of the JPEG file, and these are the magic bytes for the JPEG files. So a bunch of stuff we can't print out, and then yeah. So most of the time, it's not something we can actually see. But anyways, let's see if we can find another type of file where we can take a look at the magic bytes. So I think on my desktop, there's a PNG file. So the PNG file is here. We can take a look at, whoops, let's get the head for that. So here, the magic bytes are these ones over here. So 8954E, and we see that it spells out the word PNG. Okay, so the next thing we need to do is we need to check for its code execution condition. So file uploaded text will not work unless the web app executes code in files. PHP is a classic example, and web apps that host PHP files are a good indicator that an app is vulnerable. So we've got the web app over here, and we just want to make sure that this landing page is actually a PHP page. What we can do is we can go up to the address bar, and we can type in index.php. So if this is actually a PHP page, then this should come back. So we type in index.php, and this is actually a PHP page. So what we need to do now is we need to prepare a malicious file to upload to the application. Okay, so the very last thing we need to do is we need to have a known upload location. So even if we're able to upload a malicious file and locate it, actually no, upload a malicious file, we need to be able to locate it, because if we can't access the file, then we can't actually conduct this file upload attack. Last condition is the ability to access the malicious file that you upload to the application. So the robots.txt file in this application lets us know that there's an uploads directory. So this is where we predict we're going to be able to find the file after we've uploaded it. So let's go ahead and prepare the file. Okay, so I've got a little walkthrough for this particular challenge. If you want to take a look at it yourself, it's at GitHub over here. So we can prepare our malicious file like so. So the first thing we're going to do is we're going to create a web shell. So a web shell is basically a malicious file that can be used to run arbitrary commands on the web application that act on the web server. So we're going to create a very small web shell with this command over here, and I'll just paste in the chat. We're going to go over to our web shell, and in the web shell, we're going to paste in the command. So we're just going to echo out some contents that we're going to redirect into a file. So the contents of the file are this PHP code. And the PHP code basically says to get the contents of the 0 URL parameter. So the URL parameter that we're going to be using to activate the web shell is 0. We'll illustrate what this actually looks like in a little bit. But anyways, let's go ahead and create this file in the web shell. This creates a file called webshell.php. So we see here that we got our malicious file, and it's got the contents, the PHP web shell payload that we specified to it over here in the echo command. The next thing we need to do is we need to give this file the magic bytes for the PNG file. So remember, the magic bytes are basically the file header that lets a system know what kind of file that it's supposed to be dealing with. And we're going to be using our printf command to insert the magic bytes for PNG files into the webshell.php file. So this is what the command looks like. So we use the printf command to print out these bytes. So these bytes aren't printable, so we have to supply the bytes as their hexadecimal equivalents. After that, we're going to pipe it into the cat command. It's going to take the webshell.php file and it's going to prepend these bytes here, and it's going to output them into a file called webshell.png.php. Remember that the web application is also checking to see if there's .png in the name of the file. So we're going to submit this file name in order to get around that particular restriction. Okay, so when we run this command, we have a new file called webshell.png.php. If we read the contents of the file, we see that we've got the magic bytes for the PNG file here, and then we've got the web shell instructions in the rest of the file. Okay, so from here, what we're going to do is we're going to export this file. So this is the web shell, the picoCTF web shell. We're going to download this file, and we can download the file by giving the sz command, then space, and then the name of the file. So webshell.png.php. So that downloads the file, and then afterwards we can upload it to the application. So this is how we're going to do it. We're going to go over to the file upload page. We're going to click on Browse. We're going to select wherever we downloaded, should be in my Downloads folder. And we're going to select All Files. So all files, we're going to look for webshell.png.php. So you're going to select it. We're going to click on Open. So we've got that file selected, and then we're going to upload the file. After we do that, we get this message from the web application. So file uploaded successfully and is a valid PNG file. So we managed to successfully get around both of those restrictions. It says we shall process it and get back to you, hopefully. So this is where we need to locate the file. If we can't locate the file, then we can't perform our file upload attack. We know that there is an uploads endpoint because robots.txt showed us that it's disallowing search engine robots from looking in the uploads directory. So we're just going to take a guess that the file is going to be located in the uploads directory. So it's going to be uploads/webshell.png.php. So when we try to access the file, it actually gives us an error over here. The error is because we didn't supply the right information to the web shell. The way we supply the right information to the web shell is we go into the address bar. At the very end of the endpoint here, we're going to give the question mark. So question mark means we're going to start some URL parameters. So question mark 0, and remember we put in 0 in the code. So 0 equals, and then the name of the command we want to give. So 0 equals who am I? Who am I is going to give us the username that we're acting with for the web application. So it says we see here that there's the PNG file header that we supplied in the web shell file here, and then we get the actual output of the command that we gave to the system. Who am I? Which is www-data. So we're working as a web user right now. What we need to do is we need to locate the flag. So what we're going to do is we're just going to do a little bit of sneaking around inside the file system. We're going to give the ls command, and we just see that there's this file in this directory. We're going to see what directory we're working inside, so pwd. So we're in this directory right here. So var www html. So var www html is usually the web root of your web page when you're working inside of a Linux web server, so something like Apache. What we're going to do is we're going to take a look at the contents of this directory, but not the uploads directory, because we already know what's in the uploads directory. So it's going to be, the command is going to be ls/var www html, like this. And we see we've got these contents here. So if we find this a little bit hard to look at, we can always take a look at the page source, so the HTTP source, and this will give us the output in a easier to see format. So we've got index.php, we got instructions. We've seen all of this stuff already. So instructions.txt, we read this already. Robots.txt, we read this already. Index.php, we could read this. And we've got this unusually named file right here. So what we're going to do is we're going to read this to find out what the heck is inside of this. So just copy this, and then we're going to run the cat command on it. So the command is going to be 0 equals cat space, then paste in the name of this file. Hit enter. Oops, that didn't work because we need to give the absolute file path. Cat space /var /www /html this file name right here. And when we do that, we get the flag. So the flag is picoCTF certified expert Trickster. Okay, awesome. We're going to copy this. Then we're going to go over to the picoCTF challenge. Scroll down in the flag submission field, paste in the flag, click on submit flag, and then we're done. Okay, everybody. This was a guided walkthrough for the Trickster challenge from picoCTF, the picoCTF 2024 event. Everybody, if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out!
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.